Well, we're going to talk about the transition metals, and we probably think this has been the transition metal block, right? Right. According to the AQA definition, we should really call that the D block, and we'll see that the definition they like you to use of transition metals, actually doesn't include these elements here and these elements here. Also, we are really only concerned with the first row of transition metals, so just that, the one in period 4 there. Okay, so get started on that. Okay, so the definition of transition metals they like you to use, the one is forms a compound, at least one compound with a partly filled D shell. All right, that's the definition. Okay, so just if we do our electronic structure, you know, the last shell to be filled here is 3p. Argon, it's got 6 and 3p, and then we move on to potassium, which has got 4s1. Calcium is 4s2, and then we have to start filling up the D shell. Right, if we just draw the energy level diagram here, there's energy, and if we remember that the 4s shell is ever so slightly lower in energy, there's 4s, than the 5 3d orbitals. So there's the 3ds. Okay, so when we go to potassium, that's got 1 electron in 4s. Calcium, you've got 2 electrons in 4s. And then we move to scandium here, and we have to start filling up the D shell. So scandium would be like that, right? And of course we do anti-parallel, so we do parallel spins. So for titanium, the electron doesn't go in there, it will go in the empty orbital first of all. Okay, so scandium is D1, titanium is D2, vanadium is D3. Now chromium is a bit funny. You might expect it to be D4, but chromium is right here. Chromium is 3d5 4s1. It's not 3d4 4s2. You remember that, it's a bit of an exception. So chromium is 3d5. Manganese would be 3d5. And then when you get to iron, so we're over to iron now, you would then have to start pairing up the spins in the d orbitals. So iron is 3d6. Cobalt is 3d7, nickel 8. Copper is a bit like chromium. You might expect copper to be 3d9 4s2, but it's not. It's 3d10 4s1. Okay, so that's 3d10. And zinc has got a full shell, 3d10. Okay, so that is, and then the pattern would be repeated for the next period down. This one here, it would be 4D here. Yeah, that gets filled up. We don't really need to worry about that though. All right, so let's talk about the characteristics of transition metals. All right, now let's talk about ions. Okay, so let's take Fe. Fe is 3d6 4s2. Now, when it forms the iron 2 plus ion, the electrons, the first electrons to lose, are never from the 3d, they're always from 4s. So the electronic structure of Fe2 plus would be 3d6. The electrons are always lost from 4s, first of all. Of course, if it forms Fe3 plus, then yeah, you would have to lose an electron from the 3d orbital, and that would be 3d5 would be the electronic structure of Fe3 plus. Okay, so that's quite important to remember. It's always the 4s electrons that go. Right, characteristics of transition metals. we're probably going to say, right, 1, they have variable oxidation states. So one we're pretty familiar with already, like iron, is very often it's Fe2+, very often it's Fe3+. That's just one example. 2, they tend to form colored compounds. So a very familiar example of that would be copper 2+ ions, copper sulfate, blue, and that is all to do with the fact that it's got a partly filled D shell. A third one, which you might have heard of, is they tend to, the compounds and the elements, they tend to be good catalysts. And then the fourth one is other metals besides transition metals do this, but they form these things called complex ions, which we're not going to talk about in this video, but we'll talk about that later. Okay, so these are the 4 characteristics of transition metals that we need to think about. Right, let's go through the first row and look at the electronic structures and talk about the oxidation states that they form. So first row, I've got the first one. If you've got your periodic table next to you, you've got scandium, then you've got titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. Okay, we'll fill copper and zinc in afterwards. Right, let's do the electronic structures of those. So scandium has got 3D, that's 3D10, 3D1, sorry. We've all got 4, well, I've put the 4s in as well. So it's going to be 3D1, 4s2. Now you can put them in either order. You can put 3D first or 4s, but I think it's more logical to do that way because it's always going to lose the 4 electrons, the 4s electrons first. Titanium, 3D2, vanadium, chromium, (3D5, 4s1). That's a funny one. Manganese, iron, cobalt, right, 3D6 and 3D7. Right, let's think about what kind of ions they form then. Right, well, scandium only ever forms scandium 3+ ions, okay? And if it does that, it would have a noble gas electronic configuration. The scandium 3+ would be the same as, have the same electronic configuration as argon. That's why scandium does that. And that means scandium, according to our definition, is not, strictly speaking, a transition metal, because the scandium 3+ ion, which is the only ion it forms, would have 0 electrons in its 3D shell. So it'd be 3D naught. So scandium, not a transition metal. Right, titanium usually forms, let's put oxidation states. So common oxidation states, scandium only ever forms +3. That's all it ever does. Titanium, well, that forms a Ti2+ ion. It tends not to form 4+ ions. They're too highly charged, but it does frequently show +3 and +4 oxidation states. So 4 is when all 4 of those electrons, they're all involved in bonding. Vanadium, well, vanadium, and we have to do quite a bit about vanadium chemistry later. Vanadium forms 2+ and it forms 3+ quite commonly, but the oxidation states, it can form up to 5, up to +5. So it forms +2. That will also form +2, +2, +3, +4, and +5. That's when all 5 of its electrons are involved in bonding. Chromium, the pattern continues here. So chromium, the Cr3+ ion is the only really common ion that it forms. That forms commonly, it can form +2 occasionally, +3 very commonly, and +6, pretty common as well. And that's when all 6 electrons are involved in bonding the oxidation state. Manganese, well, that forms Mn2+ ions mostly, but it forms a lot of you can probably guess that the maximum oxidation is it goes up to +7, +2. It also forms +4 quite a lot. Anyway, iron. We know iron very commonly Fe2+ and Fe3+. We know about them already. Common oxidation states for iron really +2 and +3. It can form +6 sometimes, but it's pretty rare. We don't really need to know about that. Cobalt. Cobalt again is like iron. It forms the 2+ ion and also the 3+ ion, less commonly. So +2 and +3. I think it can also have a +5 oxidation state. It's pretty rare. We don't really need to know about it. Nickel, we don't do much about that. I just fill in copper. Nickel will be 3D 8 4s2. Nickel, we don't really need to know, but it does form the Ni2+ ion quite a lot. +2 oxidation state, most common. It can have other oxidation states as well. Copper, this is a funny one, 3D10 4s1. Copper, it does form the Cu2+ ion, which we are very familiar with, but also less familiar with the Cu1+ ion, but you come across that in like failings. +1 oxidation state. Copper's common oxidation state is then a +1 and +2. Occasionally it can form +3, but we won't worry about that. And then we get on to the last one in the block, zinc. That is 3D10 4s2. And the only ion that zinc ever forms is a Zn2+, so it just loses those s electrons. It never uses the d electrons. So the only oxidation state it forms is +2. And that means zinc is not a transition metal, like scandium, because in all of its compounds, it's Zn2+. So that means you've got a full D shell at 3D10. Remember we said definition of a transition metal is forms compounds with a partly filled D shell. So that's always full up, so not a transition metal. Just before we finish up, so we've got zinc and scandium. Let's have a look at them in the periodic table. Okay, so we've got zinc and scandium. There's scandium and there's zinc. Scandium is a 3D0 in all of its compounds, and zinc is 3D10 in all of its compounds. So by our definition, they're not transition metals. And also, if you look at this, they don't do a lot of these things. They don't form variable oxidation states. Their compounds are all white, they're not colored. They don't tend to be very good catalysts. They do form complex ions, and other things form complex ions. But these first three, yeah, they don't really do them. So that's our introduction to the transition metals then.